All right, so today we're going to look at relations and functions, and you're actually already supposed to have learned this information about what is a relation, what are the different formats a relation can be written in, how do you find domain and range of a relation, and there are 5 different ways a relation can be given to you, and each one's a little different. We're also going to look at are all of these relations functions, because not everything's a function. Everything's a relation. It goes back to that age-old saying, every square is a rectangle, but not every rectangle is a square. Every square is a rectangle because the definition of a rectangle says it has 4 right angles. Do all squares have 4 right angles? Yes. But every rectangle is not a square, because every side's not equal on every rectangle. So it's kind of that same thing. Every relation is a function, but not all functions. I want to say that. I did that backwards. Every function is a relation, but not every relation is a function. So because of that, we have to make sure we can test every relation to see if it's a function or not. So here I have the definition of a relation is it's a set of ordered pairs which can be given to you in many different ways, and there are actually 5 ways, and we're going to look at one example of all 5. Ordered pairs just means coordinate pairs. It means point numbers like 2, 4, y'all. That's what an ordered pair is. Now we're going to divide those ordered pairs apart, and we're going to write domain. Domain of a relation is a set of x's in the relation in an increasing order, and they do not repeat values. Now, in some of my examples, I may not have numbers. I may have words, but we'll treat it like numbers because sometimes you'll want to compare things that are somewhat numerical, but maybe not totally numerical, like dates. January 8th is numerical. It's the 8th day of the year, right? But when we write it as January 8th, it has a word with it. And then range is a relation, and it's a set of y's from the relation in increasing order, and they do not repeat values. So that means, like, if you have 2 y values that are both 2, you only put 2 in there one time. If you have 2 x's that are -5, you only put -5 in there one time. So we don't repeat the values when we list them for the domain or for the range. Now, it's really easy to remember which one's X and which one's Y. It's alphabetical. The D comes before R, so X must come before Y, makes it domain goes with X. Everything in math's alphabetical. Have y'all ever noticed that? Cosine, sine, cosine is X, sine is Y, C comes before S. All right, so everybody finished copying these definitions? Okay. Give y'all a few more seconds to do that. Now we're going to put some examples with these. I didn't put any examples on this page because we have 5 different ways it can be written. So I wanted you to be able to see an example of each one because there's just a set of points, there's a table, there's a graph, there's a mapping, which I'm pretty sure y'all saw in Math 2, and then there are equations. And all of those may be functions and may not be functions depending on what criteria they need to meet. A function, and we might as well write that on here because I don't actually think I wrote that anywhere. I just talk about it. A function, each x has one and only one y value. Let me explain what that means. You're in middle math class and you're working a test question. You plugged the 3 in and you got 42 and the person next to you said it was 57. Is that possible? No. If the answer is supposed to be 42 and somebody writes down a 57, I'm going to count it wrong. Because you can't have 2 different answers to plugging in the number. If you plug a 2 into a problem, everybody in the class should get the same answer. Does that make sense? So every x you plug in can only have one and only one y value that comes out of your equation. So because of that, if you have 2 x's that have different y values, it's not a function. And that's kind of what we want to look for. Do we have an x that has two different answers? If it does, it's not a function. So that's why every relation might not be a function, but every function is a relation, because every function is made of a set of points. All right. Now, is everybody getting closer? Okay.
You hit stop.
Oh.
Did you hit stop?
Nope, it started back. All right, so we're back, and we're going to continue. So here is our first relation. A relation is a set form. It's a set of points written in curly braces, so that each parenthesis is an xy value that goes together. And in this one, I have 6 points. And if I wanted to graph it, I could look at a graph. If I wanted to make it into a table, I could make it a table. But the key is relations can come in different forms, so this is just one of them. It's a very simple set of numbers. But sometimes they're not in order, which is kind of a pain. Because they don't want you to sometimes see the relationship too quickly on whether it's a function or not, or they don't want you to be able to just take the numbers and put it right down your domain and range. And so normally your x's should be in order. When you have a list of numbers, the x usually comes in order, but a lot of times with sets, they don't do that. Are these x's in order? No. Okay. So the first thing we're going to do is we're going to state the domain. The domain is basically a set of x's. So I see -3, -1, 1, 0, 1, and 2. I have 6 x's, but do I need to list them all? That's right. This 1 repeated. So I don't want to list that twice in my list. So I put -3, -1, 0, 1, and 2 because I need to make sure they're in order. From least to greatest. Increasing order, always. Now with range, you do the same thing with your y values. Well, that was the worst looking curly brace I've ever seen. Hold on. They're not easy to make. It takes a lot of practice. Sometimes I don't do a good job, and I've done it for years. All right, so what's the lowest y value? Okay, well, I see that's in there twice. I'm only going to put 1. What comes next? And next? And next? So I only have 4 of these because the 2's repeated and the -5's repeated. That's okay. So then the last thing we want to know is this set relation a function. So here's the key. Does -3 only have one answer? Does -1 only have one answer? Yeah, it does. It only has one answer too. Does 1 only have one answer? No. The x is repeated here. 1 has the answer -3 and 1 has the answer -5. That's not possible. I cannot plug a 1 into a formula and get 2 different answers back. So if the x's repeat, it's not a function. There's a clue. X's repeat, not a function. So that's a clue. If you see the x's are repeating, you know right away it's not a function, you can move right on. Now that's only one clue. Each one of these types of things might have different clues that you can look at, but that's a great clue with this because you can see all the x's. And you can look to see if they all have different y values. If they're repeating, they're not going to be. And I don't care if the y's repeat. That doesn't have anything to do with it. I can plug in -2 and get 5, and I can plug in 2 and get 5. Case in point, parabola. Doesn't this side have all the same answers as this side? So I don't care if the y's repeat. All I care about is the x's don't. All right, our next one is a table. Now, if you are making a table, it is extremely important the x's are increasing and they're in order. But sometimes they may give you a table which it is not. Mine is in order by x, but I could give you one that's not, just so you had to work harder to make your domain and range. Or to see if the x's repeat. Do the x's repeat in this problem? No, each x has only one answer. So this is going to be a function. Let's take this relation that's going to be a function and list our domain and range. Domain for this problem is going to be pretty simple. Aren't they already in order?
Yeah.
Okay. So since they're already in order, it shouldn't take too long to copy down those numbers one at a time. And since each one's only there once, it's pretty simple. Take a second or two longer to do your range because you've got to put them in order. So what order do they need to be in?
-9.
-9, -2. So always start with your negatives. The one that looks the biggest, put it first. Then 3 and 9. And I put that 9 and -9 in there to make sure that you look very carefully because sometimes you might think they're both the same. And the only thing I don't like about this table thing is it always puts everything up against the side. It doesn't let you center any of the numbers, which makes it really hard to see them. I'm sorry about that, y'all. It doesn't have a centering feature on Smartboard. So we've already determined it's what? It is a function because none of our x is repeated. So since none of them repeated, it has to be a function. So table and set are real easy to see if the x is repeated or not. That's the big clue on is it a function or not. Now it's a little different for some of the others, but that's true about both of these.
So it doesn't matter if the y's repeat.
It does not matter if the y's repeat. All right, so here's a graph. I'm going to give you just a second to copy this graph down so we can discuss it because I want you to be able to draw on it.
So we copy this down?
Mm-hmm. And I'm going to pause the video while y'all copy this graph down. So if you're watching this video for makeup work, pause the video and copy the graph. All right, so an easy way to find the domain of a graph other than list all the points so you can see them, because that is a way, y'all. And if that works for you and this what I'm about to show you does not work, then just make the list of points and then you'll have them to look at. But here's a thought. If you just look one line at a time, is there a point on, 10, 9, 8, 7, 6, 5, 4, -3? Oh, there's a point on -3. Is there one on -2? Is there -1? Is there one on 0? Is there one on 1? Is there one on 2? Is there one on 3? So I got everything from -3 to +3 for x. So you can just look to see is there one on those lines like that. The vertical lines tell you, if you look at the vertical lines, they tell you what the x value you had to go over for would be. You can do the same thing horizontally for range. So if I want to know if there are any points in the range, I'll start down here with the first one. This is 0, -3. Everybody agree? So there's a dot on -3. Are there any on -2? Are there any on -1? Are there any on 0? Are there any on 1? Are there any on 2? Are there any on 3? Well, there you go. So therefore, we have -3, -1, 0, 1, and 3. Everybody agree? So that's just a visualization so that you don't have to make the list of points. But if listing the points is more beneficial to some of you, you can list them. It's just this is a quick way of doing it. Now, we got...
The x-axis, it's just like, if you got to the same point of the x-axis, it's not functional.
Okay, so let's go back and look at that. We got to look at our x's. So when I looked at -3, there's only one point. But when I look at -2, does everybody see there are 2 points there?
Yeah.
There's not anywhere else, is there? But -2 has got an answer -1, and -2 has got an answer of 3, and that's not possible, is it? So therefore, this is called the vertical line test. Do y'all remember that? A vertical line test basically states that it will only touch one point at a time. If you put a vertical line on any given line here, it can only touch one point. If it touches more than one point, it's not a function. So this one is not a function because it touched those two on -2. Now, I don't care what it does across. I'm talking about up and down because that's what makes it not a function. You've got two dots with on the x's, and they have two different answers. Does that make sense? You only touch 1 point. PT for point. All right. The third way is a visual. This is very visual, right? The fourth way is called a mapping. And a mapping pretty much, oh wait a minute, I forgot, I had a second example. Once in a while they'll give you a relation instead of being a bunch of dots. And on this one we're only going to talk about function or not, because today I only wanted to talk about domain and range when I can see the numbers. Can you see numbers on here? So I'm not going to do domain and range on this one. I'm just going to talk about is it a function or not, because sometimes they'll connect all of it together to see the relationship that this makes a circle. Why is it not a function? That's right. It's not going to pass the vertical line test. It's going to touch twice. So this is still a relation. In fact, this is a relation we're going to learn a lot about in one of our other units. This is called a conic. Circles, parabolas, hyperbolas, and ellipses are all conics, and they are none of them functions because they have too many y squares in them. And you can't have y squares in formulas and then be a function. Case in point, if you have this formula that we've been studying, it has a y square in it. If you solve this for y, you'd have to square root it, right? And when you square root anything, you put plus or minus on it. And that makes it not a function. So when I look at the graph of this type of problem, I realize it's not going to pass the vertical line test because it's got a y square in it. Because x squared causes these two parabolas to be made and put together to make a circle. But when you have a y square also in the problem, it makes these two parabolas, and they don't pass the vertical line test. So, this is not a function. And so, all relations aren't just a bunch of scattered dots on a graph. Sometimes they're already connected up, but they're still not a function, even if I connected them, because they don't pass the vertical line test. Now we'll look at a mapping. So a mapping is two ovals or sometimes rectangles. Different shapes are used by different textbook companies. The shape is not as important as what's inside of the shape. And they'll write the word input and output on the mapping because they want to get you to understand that what is inside represents x or y. Don't you put x's in a formula, calculate it up, and get the y's back out? So the first oval is x and the second oval is y. Then the arrows connect the points so that you know which x went with which y. For example, -3 goes over here with -1 to make the point -3, -1. -1 goes over here with -2. Oh, wait a minute. -1 also goes down here with 3. Can -1 have two answers? No. So in looking at this mapping, I see 2 goes to 2 and 4 goes to 0, but I ended up with this one point here at -1 that has two different answers. And that's not possible, is it? So this is definitely not a function. Lovely relation, though. We're also going to do the domain and range here in a second. I'm just waiting for y'all to kind of get to the point where you can have the picture. Domain and range for mapping is real easy. So that's why it's so important that it's written like this. You see, if input stands for x, then that is your domain. Right? And if output stands for y, then this is your range. So in my problem, my domain is -3, -1, 2, and 4. And my range is -2, -1, 0, 2, and 3. So therefore, not too hard to copy those numbers down. They're already in order. And they're always in order because it's required for them to be in order, increasing. So table has to be increasing, and this has to be increasing, where set could be all mixed up. And of course graph I guess they're kind of just already in order in a way. So mathing's really simple. It's really easy to see, first of all, what the domain and range is. It's really easy to see, is there any answer that's pointing to two different y's? Because each x can only have one arrow coming out of it to be a function. And if it has two arrows coming out of it, it's not a function. Because that means it has two different answers. Only one arrow to be a function. Only one arrow to be a function. So that's why -1 broke the rule. He has two arrows coming out of him. Does that make sense? Okay, I've got just enough time to hit equation, which is the 5th way, and that way tonight you'll be able to do 2 sets of problems from your homework. All right, there are 2 ways equations can be written. Which part, up here? Only one arrow to be a function. That's what you're writing. Only one arrow to be a function. All right, a relation can be written 2 different equation ways. Some are explicit and some are implicit, and this is very important vocabulary, especially for people who are going into high-level math classes, because explicit are your y equal to's that are real easy to work with, and implicits are not. So this is like y equals 3x squared plus 5 as an example. And this would be like x squared plus 2y minus 7 equals 0. Something where it's not a y equal 2 equation. That's what implicit is. It's not y equal 2, where this one is y equal 2. So for today, we're going to focus not on domain and range with these, because we need to learn some special notation for that. It's not listing a bunch of points. If I give you an equation and you tell me -3, -2, -1, 0, 5, I'm going to count it wrong, because the equation never has a domain and range with a list of numbers. It's always special notation, so we're going to go into that tomorrow. I'm just going to talk about, is it a function or not? And to do that, we're going to look at a variety of different kind of equations. If it's a y equal 2 equation, that doesn't mean it's going to be a function, but it's got a better chance. If it's an implicit, we've got to look for something specific to make sure that it doesn't meet one of the criteria that would make it not a function. Okay? So I have a variety of equations here. I got a quadratic, I got an absolute value, I got a square root, and I got something that looks like everything's on one side. That doesn't mean that this one's not a function because everything's on one side. Okay? But what it does mean is we need to look for something real specific. Sometimes it might be a visualization in your head. What kind of graph does it make? For example, isn't this graph of this going to be a U? So we know this makes a parabola. If I know that makes a parabola, does it pass the vertical line test? Well, then this is a function. Because it's a quadratic. Like we studied quadratic functions starting in Math 1. Alright, this one down here is the y equal to absolute value problem. What shape is an absolute value graph?
A V.
A V. Does it pass the vertical line test? Yeah, for value, exactly. I said that yesterday, didn't I? V for value. Passes the vertical line test. It's a function. Alright, now, let's think about this x squared and y squared problem. When you think about an x squared and a y squared problem, the first thing should come to mind is things that are not going to be pretty. Because y squared is not where you want to be. Because when you square x and y, it's going to make some kind of conic. It could be a circle, it could be an ellipse, it could be a hyperbola, or it could be a parabola that opens to the left or the right instead of up or down.
Doesn't pass the vertical.
Not one of those passes a vertical line test. And every one of those would have a y squared in it. So y squared makes it not a function. So that's a big clue right away. Even if it's not all on one side, you see any y squared's not a function, because that makes it one of these shapes. All right, well, this doesn't have y squared, right? So this parabol's okay, because x squared only makes it open up or down. That one over there would have y squared in the formula. Now this last one down here has a plus or minus in it. Let's talk about square root graphs. Square root graphs look like this normally, or if they're negative, they look like this. Now if you put both in the same problem, that means you have both halves.
So it's not a function.
So it's not a function.
So, but if it's like a negative.
May I have your
If it's just a negative one, it would be a function. If it was just a positive one, it'd be one.
the auditorium?
But if it's both, it's not. Now, before you leave, you have to get through question 15 in the assignment today for 1.2. Okay? For homework. Just through 15.
Yeah, but if it's just a positive graph, then it's gonna be a function. That would be.
Okay, I got to there. So, you only have to do 1.2, 1 through 15 for tonight's homework for this video.